Hi, Fabio from Hopsworks here, and today we're going to be looking at how to build streaming feature pipelines and how to write these streaming feature pipelines into Hopsworks Feature Store. The reason we want to do this is because there are a bunch of use cases out there that not only require features to be available in real time to models, but also the same features need to be produced with low latency and being fresh for models to make the best predictions. Use cases like recommendation systems, like anomaly detections and all the type of use cases benefit from features to be computed really fast from the moment the data is generated and be low latency when data gets to the feature store. So Hopsworks support this type of use cases and support this type of feature pipelines through the use of different frameworks like Spark Streaming, Flink, and Beam. In this example, we're going to be looking specifically at Spark Streaming, but we have other videos looking at Flink and Beam as well. We're going to be looking at reading data from Kafka cluster. The same concept, the same patterns can be applied to, for instance, a Kinesis cluster or other message buses available in the major cloud providers out there. So let's have a look at how to implement one and how to run a streaming feature pipeline in Hopsworks. If you're familiar with Hopsworks already, and if you watch the other videos about feature groups, you can probably know that we have a concept of feature groups, and in this specific case, we're going to be looking at this profiles activity at 10 minutes. Here we are simulating a stream of transaction coming in, and we want to make sure that we compute some of the aggregations over the stream. For instance, the number of transactions being done by a credit card, or like the average amount of the transaction done by a specific credit card. As I said, we're going to be doing that in Spark Streaming. The first thing we have to do, though, is actually set up a Kafka storage connector. So Hopsworks has support for a wide variety of connectors, Kafka is being one of them. And we can go in the connector UI, and I already set up one that allows you to basically connect to a Kafka cluster. Here you need to provide the bootstrap servers, and you need to provide your credentials for authentication and authorization with that cluster. So you can go ahead and save it. I can check my Kafka cluster right now. You can see I have data coming in at different rates. So these are transactions coming in, and I want to process these transactions using Spark Streaming. I'm going to do that from a notebook. The same applies if you run this in a job. As always, the first thing I need to do is set up the connectivity to the feature store. So the first thing you need to do is log into the feature store, and here, as always, I need to provide the deployment information. I need to provide project and an API key, and so on and so forth. The difference here is the first thing I do is actually retrieve the connector information. The connector information allows me to centralize credentials and endpoints across different jobs, across different notebooks. And so, first of all, I don't have credentials according to notebooks, but I can also rotate them much quicker and much faster. I'm going to set up just a couple of different options for demo purposes. I'm obviously going to set up also the topic name. In this case, the topic name is credit card transactions, and I'm going to call the read stream operation on the Kafka connector. This will give me back a Spark Streaming data frame on which I can do a bunch of different operations. The first one is the first operation I'm going to do is actually the serialization process. So data comes in as a JSON objects, and I want to be able to pass these JSON objects and create a data frame out of them, right? So I'm going to use the from JSON function from Spark to be able to do that. I'm going to provide the schema, and I'm basically going to select out the values. Once I have the Spark Streaming data frame, I can actually do and compute my business logic, which in this case is quite simple. The first thing I need to do is some more cleanup in terms of like casting to values. Then I'm going to set up a watermark to be able to handle like late arriving data. And finally, I'm going to create the group by operation on the data itself. I'm going to group by credit card number, and I'm going to set up a windowing function. In this case, I'm going to set up a sliding window of 10 minutes with 1 minute slides. I'm going to compute the aggregations over those windows. As I said, I'm going to compute the average amount of the transactions within that 10 minutes windows for each credit card. Same thing for standard deviation. I'm not going to compute the number of transactions being made by that credit card over the past 10 minutes. Finally, we're going to select all the values, and I'm going to create what's going to be my final data frame I want to write into the feature store. If you watch other videos, you remember how to create a feature group. Here I'm specifying all the values and all the options that the feature group needs to be set up: the name, the version, description, the primary key, in this case the credit card number, the event time, which represents the time the window was actually generated. So that allows you to do point in time correct join, and we'll see in another video what they are and why they're useful. The difference here is I want to set up this the stream API, and I do that by setting this stream equal to option. The stream API allow me to actually write stream data frames into the feature store. It's the same for Spark, as I said, Flink, and Beam, and so on. If I have set up this stream equal true, then I can actually call this insert stream method on my feature group. What that insert stream method is going to take my Spark Streaming data frame, and it's going to execute the query automatically, and it's going to keep running it in the background. The writing process is actually quite interesting, the way we handle streaming data frames in Hopsworks. There are two different write paths, right? The first one goes to the online feature store, and it goes immediately to the online feature store. The reason for that being we want the data to be available as soon as possible for models to make inference. The second write path actually goes to the offline feature store. We don't want to necessarily write immediately to the offline feature store. The reason for that is we want to be able to batch writes to be more efficient, both when writing and also when reading. So what happens when I create a feature group with stream equal true is that Hopsworks set up a job for me. I can go in my jobs page, and I can find this profiles activity 10 minutes backfill, which actually takes the same data that the stream pipeline has actually generated, and it's gonna write it to the offline version of the feature group. You can schedule this job. You're gonna be looking at another video to do so, to run, for instance, every 10 minutes, or maybe every half an hour or so on, depending a little bit on how much data you are producing. And as I said, this job actually takes the data from the same stream and write it to the offline feature group. It also computes statistics, and it also does other like bookkeeping aspect of the Hopsworks feature store and so on. So here's how to create streaming pipelines, and you can see if you go back in the data preview, you can see the data online being available immediately, and already the job has run for the backfilling, and it's now available also on the offline feature store. That's it for streaming feature pipeline. Thank you for listening, and we'll see you in another video.